Welcome to Data Skeptic, a podcast exploring the methods, use cases, and consequences of recommender systems. Welcome to another installment of Data Skeptic Recommender Systems. Today we get into the real nuts and bolts of what it is to build and design a recommender system. You know, in machine learning, when you look at classification, everything is very standardized. Get your data into a nice tabular format, one objective column, pick an algorithm, probably XGBoost, see if the model can learn to predict the objective from the features available. But you can't just graft that model onto recommender systems. In fact, most pathways to success involve a hybrid model. Today we talk about an approach that's a hybrid method combining several components. Collaborative filtering, the classic recommender system algorithm, which effectively does dimensionality reductions. Then we talked about the use of embeddings, how you can recommend your users and their attributes and things like that in a latent space. And last but not least, bandit learning. Unlike some classification problem where you have presumably a well-sampled data set, you never know how a user is going to react to a recommender system change. When you deploy a new idea, you've got to explore it. And when it works, you've got to exploit it. Anyway, that's just a quick overview of some of the interesting topics we're going to get into right now.
Hello, I'm Boya. I'm from Virginia Tech. I'm an assistant professor of marketing in the Pomplin College of Business. Before joining Virginia Tech, I had my PhD study in marketing from Duke, so I actually graduated last year. And before entering the PhD program in marketing, I had a 2-year study of economics as a master's student in Duke as well. Before that, I had my undergraduate in statistics from China.
Could you talk a little bit about the transition? I mean, you didn't leave academia, but you went from being a student to being in the current position you're in now. Could you talk a little bit about that transition?
So I think that the biggest difference that I can tell from this transition is your role. Because that when you were a student, you just focus on your projects. And also in Duke, that PhD students generally don't need to teach because we don't have the undergraduate program for like PhD students to teach in the big school. But so far, because you have become an assistant professor formally, so you need to make some balance between teaching and research. So definitely you should be a good time planner. And also, I'm not only working on my own projects, that I'm also collaborating with the students and try to help them to figure out their research interest and also figure out our interest in common, and then we can develop some projects. And also I will provide some advice to the students. So that's something different. But in general, the research routine doesn't change that much because I still work on some projects that I started during PhD but haven't finished before the graduation.
And can you share some details on your research interest and the things you're currently looking into?
My research interest is mainly about the digital economy, especially the digital platform. And I focus both on the e-commerce platform and also how the technology such as the recommendation system could help consumers, and also how it would affect the supply side, that is the service or content provider. In addition to the e-commerce platform, that another stream of my research focuses on social media. I care about the content strategy on social media, such as the dynamics of the influencers' production of controversial content, and also how the news circulated on social media affects the offline business outcomes, such as how the news about impossible meat affects the local restaurants' adoption of this new food technology. So that is the overall of my research. And to handle all the questions I just mentioned, that I usually use the combination of tools, including the econometrics, causal inference, and machine learning tools.
When you study e-commerce specifically, as far as I know, pretty much e-commerce stores are like closed private businesses, and they're not necessarily obliged to share any data. Are there challenges, or maybe on the positive side, what data sets do you have available to study e-commerce?
Yeah, that's a really good question because you actually figure out the main challenges that many researchers, especially in the university, are facing. It's pretty hard to conduct a field experiment with the companies because they have so many other priorities for their KPI. And also, if you wanted to collaborate with them, for maybe such as conducting a field experiment, you usually need to collaborate with multiple departments because that even for the development of recommendation systems, that the departments in the firm that could be involved would include the search engineering team and also the product manager as well as the team for A/B testing and so far. So it's usually pretty hard unless that you would have some internal contact. Otherwise, that we usually relied on some public data sets such as the archive data shared on Kaggle to understand some historical consumer behaviors. Or another way is to establish your own platform for research, such as the research platform used in my paper for recommendation system was established by a group of behavior scholars from Duke that they mimic the real grocery shopping scenario, and we can recruit participants to join our experiment.
And at what point do you first take an interest in recommender systems?
The main reason why I started the research is from my own experience because the e-commerce is almost everywhere. So for me, even if some purchases will still happen offline, many of them actually happen online, right? And every time when you browse an online store, that you realize the store recommends you to recommend something to you. Sometimes the recommendations are good, sometimes are bad. And another thing is that I think my search, the entire shopping journey, was affected by the recommendations because it affects what products that I can get exposure. Sometimes that my next search is usually based on the previous search or the previous browsing, right? But the previous browsing sometimes was recommended by the website itself. So that is the one scenario. The other scenario is not limited to the e-commerce setup. It's more about the content consumption. For example, when you browse the TikTok or browse the Facebook or Instagram, that you can always see some recommended content, and also some content are the organic content, which means that they're just for entertainment, but some are actually ads. Especially Instagram, I find that the recommendation there could really understand what I would like. Many times that I was pretty attracted by the clothes or some furniture recommended on Instagram, and then I was directed to the e-commerce platform through the recommendation on social media. So you can tell that how big influence it has at least to my own life. And it's the same case for my friends' life. So I can tell that the recommendation systems is actually affecting people's life in so many ways.
Definitely, it's become rather ubiquitous. I think everyone has personal experiences, both good and bad, of recommender systems that worked great or sort of failed in maybe an embarrassing way. But those are kind of our personal anecdotes from someone in your position where you get to see maybe the bigger picture when you consider all users and all products or all possible recommendations. What sort of challenges emerge as you pursue it from the scalability point of view?
Yeah, I think that when you talk about the scalability, we should think about from two views. One thing is from the user and item level, which means that there's so many users and items online, right? The items here are not limited to the physical products we usually see on the e-commerce platform. It can also include the content product. You will browse many websites, and sometimes that you search for a target website and browse that, but sometimes you just randomly click something given your exposure at that moment. So that is the one aspect. It's just from the user and item level. But if we dive into the user and item themselves, so that refers to the second level, is that for one user, he or she can be described by so many tags because we would have a lot of footprints online so far because of the frequent visit on the website And even some offline activities can be recorded and in some way that they can be integrated with our online behaviors. And also we have our basic demographics, like where are you from, like what gender, and also what would be your education background, and so much information about one person or maybe a group of persons available, right? So for each user, the scalability would about the dimensionality of the features used to describe this person. So the same case is also applicable to items. If we think about a physical product, that we can use price, we can use a size, we can use the ingredients to describe a food, or color, or producer location, so many information, not limited to a physical product. If you look at the content product, such as the videos or audios, that themselves are unstructured data. So when we talk about unstructured data, that dimensionality is always not that small, right? And if you look at a video, it will be about some visual elements, and also would be about some like color, contrast, or some content design stuff. Even when we talk about the broadcast, the audio product, that we would have the tune, the emotion, or the pitch, right? There's so many dimensions to describe such a content product. So that is the second level of scalability. It means that the demographic space or the attribute space of an item or the person is usually high dimensional. So when we propose the algorithm to match the user and content, we need to consider both levels of the scalability, from the user and item level, and also from their attribute level.
What are the traditional approaches people used when they first went to tackle recommender systems? Like, what are the classic algorithms?
It's pretty hard to define a classical algorithm because, for the high technology like that, especially the digital technology, the technique itself is always like moving forward. And so far, it has been 2025, and we know that ChatGPT, this large language model, has been so popular. So if you ask about the classic method, like there will be a lot of options and maybe some advanced one. But if you ask me this question 3 or 4 years ago, my answer would be different. So I would not name a typical one, but I can tell you some intrinsic logic of dealing with the high dimensional data, that is to do the data reduction. So it means that in general, no matter whether it's deep learning or maybe the collaborative filtering as the one discussed in my paper, the core idea is the same, is that we're going to figure out a latent space. Such latent space is low dimensional one. But the low dimensional one can still summarize the core information that distinguish items or users in their original high dimensional space of features and demographics and attributes. It seems that we find a low dimensional space to summarize the important information in the original high dimensional space. So that is the logic. So if we are talking about the deep learning, that's the terminology we usually use for the low dimensional vector in the low dimensional space would be embeddings. Even for the unstructured data, people can transfer the unstructured one to the embeddings, that is a low dimensional vector of numbers, right? The same case here if we talk about the collaborative filtering or the matrix factorization. So the terminology is usually the factorization, the factors, the low dimensional factors that can summarize the information in the high dimensional original vectors.
I think that's an excellent perspective, that whether it's collaborative filtering or deep learning or some technique that's going to come out next year, we need a process to put data into a fixed vector, into that latent space. And maybe your mileage will vary on which is the right approach for you. Once I have that latent space where I've kind of have a feature vector on every item, can that help me with the cold start problem?
Yeah, the cold start problem is pretty salient, especially when when a website doesn't have any information about a new guest, right? Because as I mentioned, people can randomly browse many pages, like online pages every day. But if we think about the low dimensional that I mentioned, when you have such a low dimensional space, you hope that the low dimensional space can include information predictive of people's preference. But how it could be predictive? So the generation or how we can figure out such a predictive low dimensional space depends on how much we have known about the focal users or the focal items. But if I don't know about him at all, maybe it's the person's first time to visit, how can I generate such an informative low-dimensional space? That is the challenge of cold start. Cold start means that I don't have enough information that can help me to generate such an informative low-dimensional latent space.
Yeah, it makes sense that, okay, if I've been on the site for a long time and I've given you a lot of feedback, I should have an expectation that you've maybe learned me a bit better. Could you describe that process? How do we go from zero to some model of the user?
So that is related to how we design our method. So the point is that people could have its potential for a user to have a group of counterparts who share similar preferences. Right. If we know something about the group of counterparts or people who are similar to the focal new users, maybe we can use other people's behaviors to inform the potential preference of this new user. But this initialization would not be accurate, but at least it could be informative. So that is the logic, is that we don't use the focal new users' behavior to generate such a latent space, because actually we don't have this information. But it's hard for us to have no information at all, because at least you can have the person's location, right? That is usually together with the cookie, or there's so many ways for a website to have some basic information. That is the basic demographics. And then we can use this basic information and link it with another group of users who would be similar to the focal new user. And then we can use other people's preference to initialize the recommendation to the new user. It means that we estimate a prior space of the low dimensional representation for the new user, and to handle or mitigate the cold start problem.
Makes sense, yeah. I like you describe it as a prior as well, because now I'm picturing some Bayesian process or something like that, where as information trickles in, you can update it. Do you have a sense of how long something like that takes? I can't imagine if I rate one movie, suddenly you know everything about my movie taste. What does it take to get bootstrapped?
You're asking about how long do I need to really understand a new person's preference, maybe around several rounds of interaction with him. And the longer would be, let's say, 5 rounds. The shorter one would be just 1 round, as you mentioned, when you only interact with one movie, and then I can totally understand you as an algorithm. So I think that how long it will take depends on how different the focal user compares to the existing user that I can match with the new users or the people that I have known. From this view, that you can categorize the new user into two groups. One is that the user is just a normal one, means that it is a member of a majority, let's say.
Mm-hmm.
The person shares the common interest with maybe 90% of the population here. But the other case is that the person is pretty niche. She has a lot of niche preference that we don't have good representation of her type in our training data or even in our real world. For the first type, the majority one, in general, that the learning of the person's preference could be pretty fast, because our priors can be very accurate, more accurate than the priors for a niche user. But for a niche user, I think that how long do we need to spend learning the person's well depends on the learning process that we design in the recommendation system. That is the reason why in our method that we also incorporate the bandit learning. That is the effective way of learning by doing.
Yeah, I'm thinking of cases like YouTube where I don't know the statistic, but they're getting some absurd amount of videos uploaded per day. And some of those new videos are going to be very popular, but maybe a lot of them are almost garbage. They probably shouldn't have been uploaded, you know? The average video probably isn't a good video. How do you balance the process of exploring, trying to find a good video, versus saying, okay, we know enough now, this is either a good one or a bad one to be promoting?
That's also related to the prior or the starting point of your exploration, right? Suppose that you start from a random place. It means that you don't have much prior knowledge about whether the new user or would like or what kind of video, but you just randomly select. Suppose that you have 100 videos so far. And the very naive way is just to randomly pick up like 7 or maybe 1 and show it to the person and say his feedback, right? And then you use his feedback to update your algorithm for the future rounds, right? But because it's a random pick, it is very likely that the person would not like that, and you usually have a pretty long stage of learning. But think about the case that you are the user. If you cannot find the movie you like on the platform for a while, and what you're going to do, you're going to leave this platform and switch to another platform. So the consumer churning would happen. So it's always important for the firm to learn about the user's preference in a short time and to increase their retention rate to keep the customers in their platform. So the solution is like the high level intuition that we need to have a good priors. And we know even if the prior is not accurate to capture the real preference, but it can help us to narrow down the target areas that we should search for more feedback and improve our algorithm. If you start from something wrong, and it will take longer for you to go to the destination, or even maybe forever you cannot arrive in the destination, right? But if you start with something right, or maybe that's the area you explore is just around the true preference of the person, and then you will definitely take shorter time to get the point.
Yeah, I guess if you did a very naive implementation of multi-arm bandit on YouTube, I would end up much of the time seeing a video in a language I don't understand.
Yeah.
Which most of the time would be a skip. So, of course, it would be good to have another solution like collaborative filtering to kind of pick up the balance there. But how do you get these two married together?
In our algorithm design, the first step is to recognize the low dimensional space by linking the new user with some existing group of consumers, given the similarity between their demographics. And we do the same thing to the item. It means that for a new item, that we would recognize a group of existing items that share the similar attributes. Given this prior knowledge from both the user and item side, and we can generate a relatively informative low dimensional space to represent user's preference on items. But again, because this is the initialized low dimensional space, it is not accurate, but it can be a good starting point for the exploration. The next step is to do the bandit learning. Given the user preference represented by the low dimensional space, we can choose the item that so far has a potentially good feedback from a user, but it would have some uncertainties. So in general, that the objective function of the bandit learning is not just maximizing the feedback, is actually maximizing the feedbacks plus a weighted uncertainty. It means that we value the uncertainty. So the goal is to reduce the uncertainty. It means that during exploration, we're going to recommend something that we're not pretty sure the new user would like, but we know if we can collect the user's feedback to this item, even if it's a negative feedback, it will highly help us to reduce our uncertainties of understanding the user's preference. It means that the information of getting the user's feedback to the recommended item is informative, and then we'll recommend the item. After recommending the item, and we observe the user's feedback, and we include the user's feedback into the algorithm to do a Bayesian updating, and then we would have the posteriori low dimensional space. At the end, that our algorithm estimate of the user preference would converge to a stable one, and it's usually a good or the accurate estimate of the user preference.
So I know Bandit is typically an online learning technique. And of course, you could take something like Movie Lens and simulate something online, I suppose. But could you talk a little bit about the experimentation or your approach to either testing on a platform or simulating something like that?
In our paper, that as you mentioned, that we do have some empirical testing on different data sets. That the first is the standard and archive one. But as you mentioned, that bandit learning is the offline one. If we use the offline data to evaluate that, the bias is inevitable. And we also have some synthetic data, but it's still the offline one. But at the end, we conduct our online experiments on an online grocery setup. It means that we ask the participants, the real human being, to join our experiment, that they do the shoppings as what they do on Amazon or Instacart. Given their feedback to the recommended products we list on the product page, we update our algorithm, and then we have multiple rounds of experiment. It means that in the second session, the second round, and the same group of participants will be invited to do the second shopping again, and the recommended items to each user would change. The change depends on their feedback in the previous round. So we keep the algorithm updating in a live mode. So it's the same as how you interact with Amazon or Instacart.
And can you share a few details on the results?
In the experiment that we benchmark our method with another 3 algorithms, that each of them doesn't have one element compared to our method. So remember that our method have the collaborative filtering. That is the basic one that usually conducted for the user's feedback to items. But in addition to this component, we have the collaborative filtering on the demographics and the attribute, this two-side matrix, to inform the low dimensional space when we don't have the user feedback to solve the code star. And the third component is the bandit, right? So we benchmark this method with another 3 and each one doesn't have any one of the component. And overall, our method outperforms these 3 alternatives on average. That is the average result. Second, we try to figure out the source of the benefits for our method by comparing our method with each benchmark. For the category of products, such as protein, then people's preference highly rely on their demographics, which means that the priors themselves can be very informative. So the bandit learning so far is not that important. In this case, we can find that our method doesn't have a significant difference compared to the performance of the method that doesn't have the bandit learning. However, in some other categories, such as produce, I think people's preference for sure are correlated with their demographics, but not highly relied on that. It means that the demographics can only provide some information, but not all the information about their preference. So in this case, bandit learning matters a lot, because that the bandit learning can help us to collect more information, which is built on the initial low dimensional space. So it can include a lot of valuable information that the demographics and the item attributes doesn't have at the very beginning. So in this case, we can find that our method can significantly improve the performance compared to the method without the bandit learning. And overall, we find no matter which scenario it is, the data reduction is pretty important. That gets back to your question at the very beginning, is about scalability. So we know that learning from the original features, which is a high dimensional one, is slow. That is the first thing. Second, that the information integration is not good. So it cannot provide the information predictive of the people's preference, because you usually need the synergies across the multiple information. It's not the additive form of each small piece. So you need to have a model that can well integrate all of them. That is the informative data reduction. That is the second takeaway. The third takeaway is that we compare the benefits from our method across 2 user groups. One is the majority one, and the other is the minority one. The minority user are those people who have the niche preference. It means that they like something unusual, like they deviate from the mainstream or the major population's common interest. For this group of people, we find that our method, because of the bandit learning, can do better than the method that doesn't have the bandit learning. The reason is that the collaborative filtering, that is a good dimension reduction method, but because the majority usually has a lot of data in the training set, right? So they are well represented. So for them, learning about their preference can be very fast, and the priors for them can be very accurate even at the very beginning. So they always benefit from such information integration. But for the niche users, that the platforms or the algorithms understanding about their preferences are so uncertain is because their data, their preference cannot be well represented in the existing users. So the learning helps a lot. Because of the learning, that the difference between the benefits for majority and minority can be mitigated. It means that our algorithm looks more fair to both groups. So that is the three main takeaways about our experimental results.
Well, I consider myself to be one of those niche interest people in that small group, so I'm appreciative of any algorithm that can service me as, I guess, a minority in that case. I'm wondering if we could put ourselves in the shoes of that new user then. So they come to whatever platform that, let's say, is powered by your approach, and they've got to give a little bit of feedback that will then place them in that latent space. So you can kind of get a similarity, if I understand correctly. But that's an unsupervised process. So it's not like you can tell me exactly what it is without using the word eigenvector, right? It's sort of just a mathematical answer. But I, as the user, I'm going to experience it. And maybe I'll say, oh, it learned the genre of music I liked, or it learned the time period I like, or it learned something about me. Do you have any sense of interpretability between the vector and the user experience?
The interpretability of the user experience and the latent space, or how the algorithm match the observed demographics or item attributes into the low space, is very context dependent. So far, we use our method in the grocery shopping, and we can find that some low dimensional vector, because it's just a vector, it is actually a combination of multiple observed demographics and items, could be different for each product categories. For example, that for some vector in a low dimensional space, we can name it as the nutrition oriented one, because that low dimensional space is highly relevant or correlate with people's nutrition related diet or their age. But even if we apply the same algorithm into another product category, maybe the beverage, and then you would have different interpretability of the low dimensional space and their link with the observed user demographics and item attributes. So there is no specific answer about the interpretability, because it's completely context dependent.
I've touched a little bit on the topic of fairness in some other interviews. I guess, could you give us the high level of how it would plug in with your approach?
In my research so far, that I think my understanding about the algorithmic bias is more about whether the same algorithm would be different for different groups of users. If I'm a niche user, why should I always spend a longer time interacting with a website to get what I like compared to people belonging to the majority, right? It's kind of some bias, and that is what we mean by unfairness. So I think about the problem from first, the biasness in the training data that most algorithm is using, even if we have the unsupervised learning, but in practice, the good performance is usually come from a semi-supervised or some supervised learning. So we need some guidelines from the existing data, right? But what if the existing data is already biased? So different group of people can be represented differently in the existing data, and also the accuracy of this representation can be different. My research so far is try to say that how the common component in the algorithm design leverages the existing data, and as a result, how the intrinsic bias in the existing data can be transferred to the algorithmic outcomes, and people can feel that in their user experience. Whether the solution should be improving the data, or whether the solution would be more about improving the algorithm design to have a better use of the existing data. Because the people, like the proportion of different group of people is definitely not even. That's for sure, right? That's the reason why we always have majority and we always have minority. But given the data is just like that, that is the fact. And how the algorithm design can correct it or can avoid some bad outcomes that violates the fairness.
Well, I know this paper is a good milestone in and of itself, and it's just a slice of your overall research, but are there any next steps along these lines?
Yeah, along these lines, as I mentioned, that this is an empirical paper so far, and we're trying to have some like more solid exploration from a theoretical view, and to show is there any like closed form solution of the effect from different algorithm design on the fairness outcomes, and what would be the right or not right, what would be appropriate matrix of evaluating the fairness or the algorithmic bias when we include multiple groups of users or multiple group of items with different market shares or the proportion in this market. That is more like a theoretical exploration along this line. And another line would be about the effect of the recommendation system on social media. The reason is that the recommendation doesn't only affect the user experience. I mean, from a demand side, it also affects the supply side. So suppose that you are a creator, or in some cases you are an influencer. How to choose the topic of your video?
Mm-hmm.
It depends on whether you want to get more views, it means exposure, or whether you want to get more positive feedback. Maybe that we can use like to quantify the positive feedback. For sure, that the number of views or the number of likes that depend on your video quality, but it's not limited to that. It depends on who is going to receive your content. If your content is recommended to someone who already have some positive bias about that, which means that they are more likely to like it, and then it's also more likely for them to give you positive feedback. But what if your video is recommended to somebody who is more irrelevant? Even if your video quality is high enough, and you still have like less opportunity to be liked. The problem is you are not the only creator on this market. There are so many other creators. And from the demand side, the audience attention is limited. Everybody only has 24 hours. So how to compete for the attention, it depends on what other content are recommended together with your content to a focal user. So that is the next step to understand how this traffic allocation, the recommendation system, manipulate or affect the content supplier's decision about what topic to produce. Because you can choose the popular topics to produce, it's more likely for you to get exposure, but also it's always easy to get exposure for others who produce the popular topic. But the problem is that the market for this topic could be more competitive. And how likely can this small creator get more attention? But if you produce something so niche, well, the recommendation system cannot find good or the relevant audience to watch the video, and still you have some risk of having a very small positive feedback. But then how to balance that? At the end, you may find there could be some equilibrium decision on the topic choice. And then maybe on this platform, a lot of content only focus on the popular topics. It means that the content centralization is so severe, but maybe if you use another recommendation algorithm or the logic, and then the platform, the distribution of the content on the platform can be very diverse. So polarized content versus diverse content can also be an outcome of the recommendation system. So that would be the potential effect of the recommendation system on the supply side. So I would focus more on the effect on the supply side in my future research.
Yeah, I think that's rather novel. I'm not aware of a lot of good work in the supply side space. I suspect a lot of creators are desperate to get algorithmic feedback over just, things that might even be speculation that they're getting now on how to make the right video or whatever they're producing.
Yeah, because I chat with some influencer friends. They told me that even for the same piece of video, it's really hard to get popular on every platform, because the like different platforms have the different logics of allocating the traffic through their recommendation system. Even if the video quality is the same, even if that the audience base is also similar across some platforms, but still from the creator's view that the performance of their creation can still be so different. It all depends on how the content can be recommended.
Boya, thank you so much for taking the time to come on and share your work.
Yeah, thank you so much for the interview. And still, that's a good opportunity for my work to be known to the public. Yeah, thank you.
Definitely.